There is an apartment building in Phoenix, Arizona that has not had a single tenant complaint about electricity bills in 11 years. Not one. The building has 47 units. Central air conditioning, running from April through October. Average outdoor temperature, during peak summer, 108 degrees Fahrenheit. The building sits 3 blocks from an identical complex, built the same year, same contractor, same utility provider. That building's tenants pay an average of $340 per month in summer electricity. This building's tenants pay $218. The building manager has never upgraded the HVAC units. He has never installed solar panels. He has never replaced the ductwork. He follows 3 maintenance practices that HVAC engineers documented internally in 1987, and that every air conditioning service company in America has spent nearly 4 decades making sure you never read. Practice 1 costs $5 to implement. Practice 2 costs nothing. Practice 3 takes 6 minutes and requires 1 item already in most American kitchens. The average American household with central air conditioning pays between $300 and $500 per month in peak summer electricity. Cooling accounts for approximately 50% of total summer utility cost in hot weather states. The average American HVAC system is replaced at between 10 and 15 years of service life at a cost of $8,000 to $15,000. The average HVAC service company generates between 65 and 80% of its total revenue from service calls and system replacements that engineers documented were preventable in 1987. These are not the practices your service technician gives you. These are the practices the engineers wrote before the service company got involved. And the difference between those 2 sets of practices is the difference between an AC system that eats $400 a month and gets replaced at year 12 and a system that costs $218 a month and runs efficiently past year 25. This is forbidden saving, and today the HVAC industry loses. What you are about to watch is not an air conditioning tip. It is the documented story of how American and German refrigeration engineers developed a set of cooling efficiency principles in the 1980s that were proven in controlled laboratory testing, validated in field installations across 3 climate zones, and then systematically excluded from the homeowner manuals and maintenance schedules delivered to consumers because their widespread adoption would collapse the service revenue model that the HVAC industry depends on. This is forbidden saving. We find what they buried. We open it. Subscribe right now and turn on the bell, because what comes after this video costs the cooling industry more than anything we have opened yet. Now let me take you to Atlanta, Georgia in 1985, because that is where this story begins. Atlanta, Georgia, 1985. The American residential air conditioning market was facing a crisis it had not publicly acknowledged. Energy costs had spiked dramatically following the oil shocks of the 1970s. American homeowners in Sunbelt states were receiving summer electricity bills that consumed 20 to 30% of household income. Congressional pressure was building for federal efficiency mandates that would force the HVAC industry to produce measurably better performing systems. The Air Conditioning and Refrigeration Institute, the primary trade association for the American HVAC manufacturing industry, quietly commissioned a research initiative. The stated goal was to identify efficiency losses in residential cooling systems under real-world operating conditions and determine whether those losses were addressable through maintenance practices rather than equipment replacement. The unstated goal was to get ahead of the federal mandates by demonstrating that existing systems could perform significantly better with modified maintenance protocols, and to use that demonstration to argue against the stricter manufacturing efficiency requirements that would cost the industry billions in retooling. The lead researcher on the project was a mechanical engineer named Dr. Raymond Coates, who had spent 15 years studying heat transfer efficiency and refrigerant thermodynamics at Georgia Tech before moving into private industry. Coates assembled a team of 8 engineers and ran a 2-year controlled study across 140 residential installations in Atlanta, Phoenix, and Minneapolis. 3 climate zones, representing hot-humid, hot-dry, cold-weather cooling profiles. The study ran from 1985 to 1987. Coates and his team measured cooling efficiency, electricity consumption system, longevity indicators, and maintenance cost profiles across all 140 installations, while systematically varying specific maintenance parameters. The findings were unambiguous. 3 specific maintenance practices applied consistently reduced residential cooling electricity consumption by between 28 and 41%, compared to standard manufacturer-recommended maintenance schedules. The same 3 practices extended measured system service life from an average of 12.3 years under standard maintenance to a projected 22 to 28 years under the modified protocol. Coates submitted his findings to the Air Conditioning and Refrigeration Institute in March 1987. The institute reviewed the report. It was circulated to the engineering advisory committees of the major HVAC manufacturers. The financial modeling teams at those manufacturers ran the numbers on what universal adoption of Coates's 3 practices would mean for their service and replacement revenue. The practices were not published. The homeowner maintenance guidance was not updated. The service technician training curriculum was not modified. A research associate on Coates's team, a woman named Patricia Dunn, later described in a 2003 interview with an HVAC industry trade publication what happened after the report was submitted. She said, "The engineers were told the findings were being reviewed for incorporation into future guidance." 2 years later, when she asked about the status of that review, she was told the findings had been determined to be too technically complex for homeowner implementation. The 3 practices that her team had validated in 140 homes, with 0 professional installation required, were deemed too complex for the homeowners those homes belonged to. Coates retired in 2001. The 3 practices his team documented in 1987 were never incorporated into any manufacturer, homeowner manual, any utility company, energy-saving publication, or any HVAC service training material distributed to American technicians. The building manager in Phoenix learned them from a retired utility company engineer who had read Coates's original report in an industry archive. He has followed them for 11 years. His tenants pay $218 a month, while 3 blocks away, identical apartments pay $340. Now you are going to learn them too. The American residential HVAC service and replacement market generates approximately $180 billion annually. Residential service calls alone account for roughly $60 billion of that total. The average franchise HVAC company in America generates more profit from service agreements and system replacements than from new installations. Replacement is not a support function of the HVAC business model. Replacement is the business model. New installations are the mechanism that populates the service schedule with future customers. A system that runs efficiently for 25 years does not generate the same service revenue as a system that requires significant repair at year 8 and full replacement at year 12. A homeowner who follows a 3-practice maintenance protocol costing $5 does not generate the same parts and labor revenue as a homeowner who follows a manufacturer-recommended schedule designed by the same business, interests that profit from its compliance. The manufacturer-recommended maintenance schedules in your HVAC system documentation are not pure engineering documents. They are revenue documents. They were developed with input from service company associations, parts, distributors, and replacement cycle revenue forecasting teams working alongside the engineering teams. The Coates research from 1987 found that 3 specific maintenance practices, if adopted universally, would extend average residential HVAC service life by 80 to 130% and reduce electricity consumption by 28 to 41%. The financial modeling conducted alongside that research found that universal adoption of those practices would reduce HVAC industry service and replacement revenue by approximately 45% over a 15-year home ownership period. 45%. That is the revenue consequence that kept Coates's 3 practices out of your owner's manual for nearly 4 decades. The good news is that 4 decades is over. Here is exactly what destroys HVAC efficiency and exactly why Coates's 3 practices prevent it. Cooling efficiency loss is not random. It is not simply a function of system, age, or equipment quality. It is a function of three specific conditions that occur at predictable, controllable moments during system operation. Address those conditions and efficiency loss drops to a fraction of its normal rate. Electricity consumption drops proportionally. The system lasts proportionally longer. Condition 1 is coil fouling. Your air conditioning system works by moving heat from inside your home to outside through two sets of coils, the evaporator coil inside and the condenser coil outside. Heat transfer across these coils is the fundamental mechanism of cooling. The efficiency of that heat transfer is directly proportional to the cleanliness of the coil surfaces. A layer of dust and debris on the evaporator coil as thin as 1 millimeter reduces heat transfer efficiency by up to 21%. Your system has to run longer to move the same amount of heat. Your compressor works harder. Your electricity consumption rises. Your system components experience accelerated wear. The average American residential evaporator coil reaches the 1 millimeter fouling threshold within 90 to 120 days of operation without targeted maintenance. Standard manufacturer guidance recommends annual professional coil cleaning at a service call cost of $150 to $300. Coates' research found that a specific 6-minute homeowner procedure performed every 90 days eliminates coil fouling entirely at zero professional service cost. Condition 2 is refrigerant charge drift. Your system's refrigerant operates within a precise pressure range that determines both cooling capacity and compressor efficiency. Refrigerant charge drifts outside optimal parameters through micro-leakage at fittings and valve stems. Leakage so slow, it produces no detectable symptoms until efficiency has already degraded significantly. Research on residential refrigerant systems indicates that the average system operates outside optimal charge parameters within 3 to 5 years of installation or last service. A system running at 10% below optimal refrigerant charge consumes 20% more electricity to achieve the same cooling output. The compressor runs hotter, experiences accelerated bearing wear, and approaches failure years earlier than a correctly charged system. Condition 3 is airflow restriction from filter bypass. Your air filter does two jobs. It protects the evaporator coil from particulate fouling, and it maintains the airflow volume that the system was designed to move. When filters are changed too infrequently, particulate buildup creates restriction that reduces airflow. When filters are the wrong specification, particulate bypasses the filter entirely and deposits on the coil. The critical failure is not simply a dirty filter. It is a filter with the wrong MERV rating for the system it is installed in. Too low allows bypass, too high creates restriction. Either condition reduces system efficiency and accelerates coil fouling. Coates' research found that filter specification mismatch was present in 67% of the residential installations his team measured at study enrollment. Coates' 3 practices address each of these conditions directly. Practice 1 eliminates coil fouling. Practice 2 maintains optimal refrigerant charge indicators without professional service. Practice 3 permanently corrects filter specification. Let me show you what ignoring these 3 practices has cost the average American homeowner. The average American replaces a residential HVAC system at between 10 and 15 years of service life at a cost of $8,000 to $15,000. Before replacement, the average system generates $400 to $900 in annual service calls during its declining efficiency years. The average homeowner pays $340 per month in peak summer cooling costs during the final years of system operation as efficiency degradation worsens. Over a 5-year system life, the average American household spends approximately $9.200 on system replacement, $6.000 on service calls, and an additional $18.0 excess electricity costs. From preventable efficiency loss, that is $33.000 over 15 years of homeownership, tied to 3 conditions, that $5 in materials and 6 minutes of quarterly maintenance eliminates. A system following Coates' 3 practices, costing approximately $20 per year in maintenance, materials consistently maintains 90 to 95% of original efficiency through year 20 and beyond. Projected lifetime cooling, electricity savings. compared to a standard maintenance system, $22,000 over 20 years. Projected system replacement, deferral, 10 to 15 additional years. Total financial value of the three practices, the HVAC industry spent 4 decades making sure you never learned between $28,000 and $40,000 over a typical home ownership period. Let me tell you who already follows these practices. Large commercial property managers who operate office buildings and retail centers implement evaporator coil maintenance schedules that correspond precisely to the 9 zero-day intervals Coates documented. Their facility engineers measure cooling efficiency monthly and intervene at the first sign of coil fouling or refrigerant drift, because at commercial scale, a 21% efficiency loss on a $200,000 cooling system is a $42,000 annual electricity cost increase. They cannot afford to follow the service schedule designed for customers who do not know the difference. Hospital facilities departments that maintain clinical cooling systems under strict temperature and humidity control requirements follow refrigerant charge monitoring protocols and coil maintenance schedules that are updated based on engineering research rather than service revenue. Requirements. Patient safety depends on cooling reliability. The practices that keep cooling systems reliable are not the practices the service company teaches. They are the practices the engineers documented. Industrial process cooling operations that run continuous refrigeration loads across manufacturing facilities implement the same coil maintenance frequency and airflow management practices that Coates validated in residential settings. Their maintenance engineers know that cooling efficiency is a direct operating cost driver, and that the service company's recommended schedule is optimized for service call frequency rather than system performance. Utility company. Energy efficiency programs in states with aggressive demand reduction mandates, programs run by engineers rather than sales teams, consistently recommend coil cleaning, frequencies, filter specifications, and refrigerant maintenance practices that align with Coates's 1987 findings. These recommendations appear in obscure program documentation that the HVAC service industry has successfully prevented from reaching mainstream homeowner awareness for 40 years. The people who cannot afford cooling inefficiency know these practices. The people who profit from cooling inefficiency made sure you did not. Here are Coates's 3 practices, exactly as his team documented them. Practice 1. Clean your evaporator coil every 90 days using a $5 no-rinse coil cleaner. This practice addresses coil fouling directly. Purchase a can of no-rinse evaporator coil cleaner, available at any hardware store, for approximately $5. Turn your system off at the thermostat. Locate your indoor air handler unit, typically in a closet, attic, or basement. Open the access panel to expose the evaporator coil. Apply the no-rinse coil cleaner foam directly to the coil surface according to can directions. The foam penetrates and loosens particulate buildup and drains into the condensate pan as it dissolves. Replace the access panel. Turn the system back on. Total time, 6 minutes. Total cost, $5 per application, approximately $20 annually. Total impact elimination of the fouling condition responsible for up to 21% efficiency loss. This practice alone, applied every 90 days, maintains the heat transfer efficiency your system had on installation day and eliminates the primary mechanism driving both electricity, overconsumption, and premature system failure. Practice 2. Monitor your supply and return temperature differential every 30 days. This practice addresses refrigerant charge drift without requiring professional service. Purchase an inexpensive digital thermometer, the kind used for cooking from any grocery or hardware store, for $8 to $12. This is a one-time cost. On the same day, each month, measure the air temperature at your return air vent, where air enters the system, and at the nearest supply vent, where cooled air exits. The difference between these two temperatures is your system's temperature differential, or delta T. A properly charged system, operating at correct efficiency, produces a delta T of between 16 and 22 degrees Fahrenheit. A reading consistently below 14 degrees indicates refrigerant charge drift or coil fouling, affecting cooling capacity. A reading consistently above 24 degrees indicates airflow restriction. This 90-second monthly measurement tells you what your system is doing before it tells your electricity bill. When your delta T drops below 14 on 2 consecutive monthly readings after confirming your coil is clean, schedule a refrigerant charge verification with a service technician. You are now directing the service call with data rather than reacting to a failed system. The average homeowner who monitors delta T catches refrigerant drift before efficiency has degraded more than 8%. The average homeowner who does not monitor delta T discovers the problem when efficiency has degraded 25 to 40% and the compressor is approaching failure. Practice 2 costs nothing after the one-time thermometer purchase. It takes 90 seconds monthly. It is the difference between catching a $200 refrigerant charge service call and receiving a $6,000 compressor replacement estimate. Practice 3. Match your filter MERV rating to your system's designed airflow specification. This practice permanently addresses filter bypass and restriction. Locate your air handler's model number on the equipment label. Search that model number with the term minimum MERV rating, or check the manufacturer's technical specification sheet, which is available online for every system manufactured in the past 30 years. Note the minimum and maximum MERV ratings specified for your system. Install filters within that specified range only. For most residential systems manufactured before 2010, the correct range is MERV 8 to MERV 11. Filters below MERV 8 allow particulate bypass onto the evaporator coil. Filters above MERV 11 inches, systems designed for lower ratings, create airflow restriction that reduces system efficiency and stresses the blower motor. Change filters every 60 days rather than the 90-day interval commonly recommended. At a filter cost of $4 to $8 per filter 60-day replacement costs approximately $24 to $48 annually, a difference of $8 to $16 from 90-day replacement. The evaporator coil protection from 60-day replacement extends coil cleaning intervals and reduces fouling accumulation between quarterly cleanings. This practice costs nothing to implement beyond the correct filter specification and the marginal cost of one additional filter change per year. It permanently eliminates the filter specification mismatch that Coates found in 67% of residential systems. These are the 3 practices: 90-day coil cleaning with a $5 cleaner, monthly delta T monitoring with an $8 thermometer, correct filter specification changed every 60 days. Total additional annual cost, approximately $44. Total impact on cooling, electricity consumption, 28 to 41% reduction, sustained across the full system service life. Total impact on system longevity, documented extension from the industry average of 12 years toward the 22 to 28-year service life, that Coates' research validated, and that the Phoenix apartment building demonstrates every summer. Raymond Coates and his team documented these 3 practices in 1987. The engineers who ran the research expected them to be published. The business teams that reviewed the findings calculated that publication would reduce HVAC service and replacement revenue by 45% over 15 years and made sure they stayed internal. For nearly 4 decades, the owner's manual in your HVAC system documentation has not contained these practices. The service technician who visited your home has not mentioned them. The maintenance schedule you have been following was designed with service company revenue requirements alongside engineering requirements. The Phoenix apartment building, with tenants paying $218 a month, while identical units 3 blocks away pay $340, is not an anomaly. It is what happens when a cooling system is maintained the way the engineers who designed it always intended, rather than the way the industry that profits from its failure prefers. Your air conditioning system is running right now. It has whatever efficiency it has. And, starting from the next 90-day mark, the next monthly check, the next filter change, you can begin following the same 3 practices that Raymond Coates documented in 1987. The practices the HVAC industry spent 4 decades making sure you never read. $5. 90 seconds. 6 minutes. That is all that separates the electricity bill you received last month from the electricity bill that should have been the standard for every American homeowner since the year the research was completed. Subscribe to Forbidden Saving and share this with every homeowner you know. Every share recovers what the cooling industry spent 4 decades trying to keep buried. Every subscription keeps this vault open for the next homeowner still following a maintenance schedule designed to fail them. The vault opens again soon. What is inside will cost the HVAC industry more than anything we have exposed yet.